Have you ever, stopped for just a second to think about that little tap you do every day? Getting on the bus, the subway, you're maybe half asleep, reach for your transport card, tap, green flash, and you're on your way. It's so simple, right? So automatic, we barely notice. But there's actually some pretty amazing stuff hidden in that little moment.
It really is quite something. And it makes you think, doesn't it?
Yeah, I remember the old days, not that long ago, really, buying those little paper tickets, remember those?
Yeah.
From the booth, handing over the little slip. Feels like a whole different world now.
Oh, definitely. Those paper tickets are pretty much gone, replaced by these plastic cards that just seem, well, effortless.
Yeah, but that's the thing that gets me.
Right. The convenience is huge, no question. But the really fascinating part, for me anyway, is always, okay, how? How does this little piece of plastic, no battery you can see, no wires plugged in,
Yeah.
how does it instantly talk to the terminal? How did it handle payment? It's not just sitting there passively, There's something really clever going on inside.
Exactly. And that's what we're diving into today. For you listening in, that's our mission. We're going to try and pull back the curtain on the secret behind your transport card. And we'll break it down really simply, first steps into understanding electricity. We're borrowing some great ideas from John Byung-Chul's book, Byung Chunk Gri, which is perfect for this.
Yeah, it's a great starting point. We're basically looking at the core idea, electromagnetic induction, and the tech that uses it in your card.
Yeah.
That's near field communication, or NFC. Simple name, but pretty powerful stuff.
Okay, let's get into it. The first big mystery, the one we kind of touched on already, the card. It's just plastic, right? Thin, maybe credit card size, sometimes smaller, no battery.
Yeah.
So how does it get the juice, the energy to send information, to tell the machine, here's my number, deduct the fare? Where's that power coming from?
That's a perfect place to start because, well, it gets right to the heart of the design. Think about it. For the card to do anything like send us unique ID or the fare amount or even just the time and place you boarded, its little internal chip needs power. It has to wake up. Without power, it's just inert plastic. It can't process, can't communicate. So it absolutely needs energy from outside right when it needs it. And that's where electromagnetic induction comes in. It's how the card powers itself up on the spot.
Right, okay. Electromagnetic induction. Sounds technical, but you're saying it's the key. How does that work? How does it power the card seemingly out of nowhere? Let's simplify it. Picture the two main things involved. The terminal on the bus or gate and your card.
Exactly. Two key players. So the terminal first. That machine you tap against, it's actually plugged in, right? It's got a constant power supply. And because it's always powered, it's always doing something subtle but really important. It's generating a magnetic field around itself, a changing one. You can almost imagine it like an invisible energy bubble just pulsing around the terminal, waiting. Kind of like a speaker sending out sound waves you can't see, but these are magnetic waves.
Okay, an invisible magnetic bubble. Got it. And then there's my card. Inside the plastic, which you can't see, there are tiny wires coiled up.
That's right. Really fine wires coiled around many, many times, like a little flat spiral. And these coils are connected directly to a tiny computer chip. That's the card's brain, essentially. It holds all the important info.
Ah, okay. Coils and a chip inside.
Yep. So now, here's the moment, the physics bit that makes it all so convenient. When you bring your card close to the terminal, maybe just a few centimeters away, those coiled wires inside your card enter that magnetic field we talked about. They cut through the magnetic waves. And that interaction, the wires moving through the changing magnetic field, it induces electricity. It actually creates a little electrical current right there inside the car's wires. It's like, those old bike lights powered by a dynamo on the wheel. As the wheel spins, magnets and coils interact to make power. It's a similar idea, but invisible.
Wow. Okay, so just getting close makes the card generate its own power, instantly.
Pretty much instantly, yeah. Just the act of entering the field gives it that burst of energy it needs.
Once it has that power, the little chip wakes up.
Exactly. The chip springs to life. It reads its stored data, your ID number, balance, whatever it needs, and then immediately sends that info back to the terminal using that same energy.
It's a super quick conversation then, powered by proximity.
It's incredibly fast. The whole communication happens at a specific radio frequency, usually 13.56 megahertz. That's just the channel they use to talk. But the entire sequence, sensing the field, generating power, chip activating, reading data, sending data back, happens in, a tiny fraction of a second. Blink, and you miss it.
Which is why it feels instantaneous when you tap.
Oh.
Okay, but then why do I have to tap it so close? If it's using radio waves and magnetic fields, why can't I just wave it from, across the barrier? Or even further away?
Good question. And the answer is actually really neat. That short range isn't a bug, it's a feature, a really important one. Because this whole process, the power transfer and the data transfer, relies on that close-range electromagnetic induction.
Mm-hmm.
It only works over typically just a few centimeters.
Okay.
And that's why it's called near-field communication,
Yeah.
NFC. The near-field part is key. That short range is actually a massive security advantage.
Security. How so?
Well, think about it. If it worked over long distances, your card might accidentally get read when you don't want it to, like paying for someone else's ride by mistake. Or, worse, someone could potentially try to intercept your card's data from afar. But because it has to be so close, literally near, you have to make a deliberate action to tap. It makes it really hard for accidental reads or for someone sketchy to grab your info. So that limitation is actually built-in security. It keeps your transaction private and intentional. Pretty clever, huh?
That actually makes perfect sense. Yeah. It's not a flaw, it's the point. Near field. Okay. And NFC, this whole near field thing, it's not just for transport cards anymore, is it? Once you kind of get the idea, short range, secure tap, you start seeing it elsewhere.
Oh, absolutely. You really do. Once you know the principle, you see NFC popping up in lots of places beyond getting on the train.
Mm.
Think about electronic tickets for gigs or events, often just a tap of your phone or a card.
Right.
Or paying for coffee with your phone or smartwatch. That tap to pay uses NFC. Even like in museums sometimes. You might tap your phone against a little sign next to an exhibit to get more info sent straight to your device.
Huh. I think I've seen those.
Yeah, so it's used for payments, for access, for quick information transfer, all kinds of things where you need that simple, secure, short-range wireless connection.
It's kind of amazing, really. This basic physics idea, electromagnetic induction, leads to NFC, which then becomes this quiet workhorse behind so many of our smart gadgets, helping them talk to each other wirelessly, efficiently, and, like you said, securely, just by being close. Makes life a bit smoother.
It really does. Little bits of hidden science making things easier.
So there you have it, that super quick, everyday tap. Turns out it's not so mundane after all. It's this invisible dance happening. Magnetic fields making electricity, powering a tiny computer, all in the blink of an eye. It just shows how much cool tech is built on these fundamental science ideas, even when you explain them simply. It's pretty mind-blowing, actually.
It really is. And I think, understanding a bit about how these everyday things work, it just makes you appreciate them more. Gives you this little bit of knowledge, lets you see the cleverness hidden in plain sight. Knowing the why behind stuff you use all the time, it's empowering, I think. Fuels your curiosity.
Totally agree. And that actually leads to a really interesting thought to leave everyone with. So we know NFC works great for these short distances, like our cards, because of how the power transfer works. But what about the next step? What about powering things wirelessly over longer distances? Not just centimeters, but, further.
Yeah. That's the big frontier, isn't it? True wireless power over meters or even more.
Right. Imagine if your phone just charged itself while it was sitting on your desk or even just in the room. No cables, no pads.
Or think about medical implants, maybe. Being powered
Yeah.
from outside the body, no need for surgeries just to replace a battery.
Wow, yeah. Or sensors all over a city and monitoring traffic or air quality, just pulling energy out of the air somehow, never needing a battery change.
Exactly.
Yeah.
The possibilities start sounding a bit like science fiction, but, today's engineering challenges often come from yesterday's sci-fi ideas.
For sure. So that's the question to ponder. If we could crack that long-range wireless power problem safely and efficiently, what kind of totally new things would that make possible? What new conveniences could we not even imagine yet?
Definitely something interesting to think about.
Yeah. Keep that in mind next time you hear that little beep when you tap your card.